Sir.
All right. Thank you so much for joining my class today. I'm sorry we had to start a bit late, 15 minutes late, okay, because I was in the midst of sending my daughter to school, but okay now. All right. So today, inshallah, we will continue with chapter. We'll start with chapter 4, okay. Basically, we'll start with chapter 4. What we have done so far in chapter 3, we have talked about processes. Okay, we have talked about processes. We have highlighted what is a process and what are the states in a process. What is the meaning of a process itself? And we've also talked about PCB, process control block, and what are the features or what are the elements, properties inside each process. And we've also touched about threads. If you remember, we have also touched about threads. So today in chapter 4, we will continue with a bit more detail about threads and how it's being done in the, how is it being used in the operating system, or how does the operating system handle multiple threads. Okay, so this is chapter 4. Okay, so basically overall, we are going to understand what is thread itself. Okay, what are the thread issues? Okay, there are certain issues related to threads. We'll understand the why is a thread necessary and how does a thread work actually. And we are also going to understand, which is the most important part of this chapter 4, which is what is a core. Okay, so we have a single core, we have dual core system, multiple core system, and so on and so forth. Okay, and how does this core processor and thread work together side by side? All right, so basically the operating system is to handle all of these processes, okay, linked to the core. Okay, a core is sorry, a core is a hardware which is inside the personal computer. However, the job of the job of the operating system is to push any process which needs to be executed inside the processor. All right, so inside the processor there is a core which handles all the processes. So when you're talking about single core, that means there's only one process running at one point of time. But when you talk about dual core, that means there are two brains working inside one processor. Okay. All right. So let's start with the introduction. Okay. All right. Most modern application runs are multi-threaded. Multi-threaded means from one process they can be broken down into multiple sub-processes. From one big process you can open multiple small processes, but all these processes are linked to the big process itself. Example, if you have your Microsoft Word running, you can open multiple documents at one point of time. Okay, so thread runs within the application. So Microsoft Word is an application, so the thread is running under the application, or the thread is running within the process itself. So if you close one thread, your application or your process still continues to execute. However, if you stop the application or process, any thread which is running under the process stops by itself. It's like this. If you are driving a car, okay, the engine of the car is the process. The tire movement, the brake system, the signal system, the aircon system are all threads. Once the car stops, then the whole thread, the tire stops, the aircon stops, the radio might stop, everything else stops together. But if you, let's say, if your car indicator does not work, that does not mean the car is not working. The car still works. The car still can run. Okay, here the car can still move from point A to point B. But if the car itself has some problems with the engine, then the car would not run. So making this small threads all it will stop by itself. So thread runs within the application. Multiple tasks with the application can be implemented by update display, fetch data, spell checking, answer a network request. So these are the tasks related to each of the thread. Okay, so each thread is a sub-process by itself. However, okay, remember, okay, however, each of these sub-process, each of these thread share the similar task certain times. That means they share the similar task at times. Okay, although they are running separate, okay, separate tasks, separate processes, but there are certain tasks that they share themselves. Example, if you open Microsoft, Word document, okay, document 1, you're opening Microsoft document 1. Okay, let's say you are doing a print, okay, print service. So when you a print task, so when you do a print task on document 1, okay, document 2, 3, 4, and so on can continue the process, but it cannot do print task because task is a feature where it's shared by all these threads. Okay, there are certain tasks which is shared by all these threads. Okay, so for example, print. For example, save. So if you are doing save, you're going to save your document 1, document 2, 3, and 4, and 5 cannot use this task yet until the first thread is complete, has completed with the task, with the save. Only then it can move on to the next one and next one. Okay, so there are certain tasks whereby it cannot be run in all different threads. Okay, certain, not all, but certain. So in this slide here, it shows update display. That means there are certain displays that needs to be updated on the screen. So those tasks cannot be automatically shared by all the threads. Okay, fetch data, spell checking. Okay, when you do a spell checker, okay, you can only do it in one thread. You cannot do it in multiple threads. Once you finish spell checking your document 1, then you can do it in document 2, and once you finish in document 2, then you can move on to document 3 or 4 and 5. Okay, all right. So process creation is heavyweight, while thread creation is lightweight. When you create a process, when you first initialize a process, yes, it takes some time, especially when you're running. If you have a low spec processor, then the first time the process opens, then it takes some time. So that's why it says it's a heavyweight. While the thread creation, when you open document 1, document 2, it's very fast. If you are using Photoshop, for example, when you open the program, yes, it takes some time, but each time you open a project, it's very fast. Okay, it's very fast. All right. So when you do threads, it is also linked to your operating system and it's also linked to your kernel. So what is a kernel? If you remember from chapter 2, kernel is actually the brain of the operating system. So the kernel also needs to make sure which thread is running and which thread is using which task. All right. So this is an example of a multi-threaded service architecture. Multi-threaded. Okay. Again, when you say multi-thread, it means multiple threads, multiple sub-processes. So each client here, what is the client? The client is a thread. Okay. The client is a document 1. Okay. The word request from the server. What is the server? the server is the operating system. Okay, so the client will request to create a thread. Okay, client will create a new thread to service the request, because you have to remember each process which is run by the operating system is considered to be a service. And what kind of service is this? The service that we are talking about in this particular site is to open a particular program. So how many services are there available in an operating system? Refer to chapter 2 and 3. You can see there are few types of services which are related to the operating system. There are about 5 services, among which is file sharing, process creation, security and protection. So these are the services provided by the operating system service. Okay. All right. So what is the benefit of having threads? Why do we need to have threads? Well, it's much more responsive, may allow continued execution if part of the process is blocked, especially important for the user interface. Resource sharing, economical, scalable. Okay, so why do we need to have a thread? A thread is very useful because it allows the user, okay, to continue execution. You can still do your document, although your Microsoft Word has some problems. Okay, it's not, let's say, is the serial number is not valid or is already expired, but you can still do your documents because it allows responsiveness. It allows you to continue using thread, although the process has some problems. Okay, thread allows you to share resources, so you can share the memory. Okay, the memory, as you know, each process before it's being executed is brought to the memory, and after that, from the memory it goes to the processor. Okay, economy because it's cheaper than process creation, thread switching, lower overhead. Okay, so when you create, let's say example, okay, if you create another, let's say you want to open a document 1, but you don't have to open the Microsoft Office again, because if you do that, then it's going to take much more time. So the operating system allows you to create threads because it's much more faster. Okay, it's more economical. Because if you were to stop and open your Microsoft Word again, then it's going to take time, especially when you're dealing with slow, high-end, slow PCs. Okay, and it's much more scalable. Processors can take advantage of multiprocessor architecture. Multiprocessor architecture means you have multiple processors running at one particular point in time. Scalable means it can be extended. Okay, it can grow. That means you can run multiple processors and at the same time run multiple threads at the same time. So you can have Microsoft Word with 5 documents, Excel with 5 sheets, PowerPoint with 5 slides, all running at the same time. But the operating system and the processor only knows that this user is running 3 processes. The threads are all handled by the process. Okay, the thread is being handled by the process. The operating system only handles 1, 2, 3 process: Word, Excel, and PowerPoint. Okay, so this is, now we go into core. Okay, what does a core mean? A core means, let's just skip this chapter and skip this slide and come back to this slide later. What is a core? Over the years, processors have emerged from single core to dual, quad, octa, hexa, deca core processors. Core is usually the basic computational unit of the CPU, which handles maths and logical operation. A CPU with more cores can perform more tasks at a time. Task here refers to more processors. Okay, so if you have a single core, yes, it's good. Okay, but if you have a dual core, meaning you have 2 brains running at the same time, then you run faster. Which actually is not a brain. Okay, the processor, you can say, is the brain. Okay, but a core means, if you put it in your human brain, it's like, you can say, the right side of the brain and the left side of the brain. So the human brain works as if The right side will control certain activities of the human, and the left side will control certain activities of the human. Similar situation happens in a dual core. Okay, a dual core. That means dual core means both core can run simultaneously and run more process at one single point in time. Okay, a single core satu je processor is a microprocessor with a single core on a chip running a single thread on a single process. That means it can handle only one process and one single thread. That means if you take Microsoft example, if you put it here, is basically you can only run Word and document Word. That's it, because you're running at a single core. Single core was impossible to achieve performance gains like increased clock speed, increase the number of transistors on a single chip, increase CPU cache, and adding execution units. Okay, so when you have a single core, so it's difficult for you to get the best out of the processors, because you can only run one process and one thread at one single given point of time. But if you're running with a single core, again, only has one core, which means it can only start one operation at a time. Okay, so these are your applications or your processors, and this is the CPU, meaning to say application 1 or process 1 runs, 2, 3, and 4 cannot run, cannot execute. Once process 1 has completed, only then you can move on to the next process. So in a single core, you can only run one application and one thread. Okay, once this is done, habis, then you can go to the next one or the next one. So inside the application or inside the process, you can have one process and one thread only. This is a single core. In a dual core system, okay, so we have this chip like this with two processors or two execution cores. Okay, these two cores are linked together, therefore they can perform operations faster than a single core. Each processor has its own cache and controller, which enables it to function as efficiently as a single processor. Meaning to say, each core would have its own registers, its own cache, and another core will have the same thing as well. Right? So go back to this slide. So what does this mean is, in a single core, since you are only allowed to run one particular process and one particular thread. So in a single core, you can the operating system, since you have many threads at some times, so it allows the users to run one thread for a single period of time. Base time 2, then it moves to the next thread, then goes back to the first thread. Okay, so in a single core system, you can only run one process, one thread. Tapi what it does is, each thread runs in a certain given period, certain time. Okay. In a multiple core, yes, you can run two cores, two processes at one time, and you can also do it. Each thread runs for a certain period of time. So this and this are not related at all. Okay, this thread is not the continuation of thread number 2. No. Okay, so you can run all at the same given point of time. Or the operating system can do two threads from the same processor. Okay, because you have to remember, in a multi-core system, the operating system allows users to run two processes and two cores. That means you have two threads. So that means process 1 has a thread, process 2 has a thread. Okay. All right. So that's a dual core. How multiple core process works. The operating system also tells the processors to execute more processes simultaneously, depending on the cost of each processor. Within a processor, there are multiple levels of cache memory that holds data for processor's next operation or operation or next operation or operation. Okay. So what does this mean is, so this is the processor. Processornya tetap satu, but the brain is now left hand side, right hand side. So this has its own cache, this has its own cache, and it's all linked to the RAM. So now the operating system's job is to tell the processors to execute more than one process, and once the process comes inside the RAM, it will be passed according to the core. Because if you remember, to execute a process, you need RAM and processor. Okay, so you have that. But now you can run two processes at one point of time, but it's now divided into several cores. So this is a dual core. So if you have 3, 4, 5, 6, 7, 8 cores, then you can run multiple processes at one given point of time. Okay, so you can run multiple. So in my PC is i5 core. Okay, so what does this mean? This means I have 2 cores running at one point of time. So I can run multiple multiple processes at one point of time. But some people will ask me why it's not, because you're running only two processes. So Microsoft Word is already one process, PowerPoint slides are another process. Yes, but if you refer back to this slide, each of them have a time. So the operating system will switch between the threads. Okay, switch between the threads. Each thread is given a certain period of time, so it will continuously change the thread. Okay, all right. So this is another diagram of how we say a single and multi-threaded processes. Okay, so this is a single-threaded processes, or we say as the single core. So a single core, these are all, this one here is the files of the first process, and this is the thread for one process. So this is one process, and this is one thread. In a multiple thread, we have 1, 2, 3 processes running at a time, and each of the process can open up to a thread by itself. And as you can see, each of these have their own code register stack. Okay, data are all here. That means these things are all related to this. These things are all related to this. These things are all related to this. So one shaded region here is one process, one process, one process. Okay, this is how a multi-thread looks like. Okay, so user thread and a kernel thread. Now we jump on to what is a user thread and what is a kernel thread. Okay, so a user thread is all the processes that the user runs. Okay, the user runs. So the operating system will handle the user threads. The user threads are all the application related to the user. So it can be your Microsoft Word, PowerPoint, Excel, and all those programs that a user is running. So those are the user thread. A kernel thread, on the other hand, is different. A kernel thread, because if you go back to the explanation of a kernel sits inside the operating system. Okay, sits inside the operating system. Okay, so now you have the operating system running 3 proses, 1, 2, 3. Multi-thread lah, 3. Tapi operating system dia it's still one. And inside the operating system there are kernel. So the kernel is handling the operating system. But now you have multiple threads. So operating system sekejap it has to go to process number 1, sekejap it has to go to process number 2, sekejap it has to go to process number 3. Banyak ni. So what the kernel does is the kernel also will break up into threads. So the kernel will handle one OS, another kernel will handle, kernel thread will handle another OS, another kernel thread will handle another OS. Okay, so let me just go back to the previous slide. Okay, so these are all processes. This is a process. Okay, this is a process. This one process, two process, three process. All of these processes are handled by the OS. Okay, and the OS is handled by a kernel over here. Okay, since the OS is going to handle multiple process and all the threads here, so now the kernel pun kata, okay, I pun nak buat thread. So now it breaks up into a few threads as well. So akan ada satu sini OS thread and another one here. Okay, so the kernel pun break down. So this OS will handle this one will handle this one here. Okay, so each of the kernel threads will handle one particular process, or will handle one particular OS, which handles one particular process. Okay, are you with me? A bit tricky here, because we say that the OS is going to handle all the processes, but now we have more than one process and we have multiple threads. So it's going to be very hectic for the operating system. So what the kernel does is, the kernel pula akan buat kernel thread yang akan handle OS ni, dia akan handle separate OS. Okay, but all is actually one lah, tapi dia akan break down juga. Okay, so the kernel thread for this OS will handle this process. The kernel thread for OS number 2 will handle this. The kernel thread for OS number 3 will handle this. Okay, so it breaks down into separate kernels as well. So these are examples of operating system which has kernel threads. Are you with me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
All right, so now we go into multiple thread. Okay, so multiple thread meaning document 1, 2, 3, 4 dan banyak-banyak lagi dokumen pointing to one process. Okay, pointing to one process. Yang ni pula one to one, meaning one thread, one process. Yang ni pula many process, many threads. Okay, so these are the kernel thread. Many user level threads map into single. Okay, multiple threads may not run in a parallel multi-core because only one may be kernel, one may be in the kernel at one given time. So this is what we say as A. Okay, in this case, we have one kernel running multiple user threads. What does this mean? Meaning to say, ini ialah, ini semua satu, ini kalau saya bikin macam ni, this is, saya nak padam. Is it on? Okay, so this semua is the OS. Okay, OS, which is this one lah, ni example dia. But since kernel ni buat thread, so this one dia ini untuk satu, ini untuk satu, ini untuk satu. And then this thread, this OS thread, ni OS thread can do process. Macam tu. Can do process. Can do process. Can do process. Dalam proses ni can have threads. Threads and threads. Okay. So as you can see, what do you see here? You see here they have one to many. One kernel having many user threads. User thread ini ialah the operating system. Operating system. Tapi actually is only one operating system lah. Tapi operating system tu pun dia pecah-pecahkan. So that you can run multiple processes at one point. Okay. Alright. Yang ini pula. This is a bit tricky pula. Each user level thread maps to kernel thread. So yang ini pula it's multiple kernel. We have beberapa kernel. But each kernel can only run one thread. One thread. What's the difference between this? This can run multiple processes. This pula, dia cuma satu proses je. One process. One process. One process. Okay, because the kernel tu sendiri dipecahkan. Yang tadi tu, okay, OS dipecahkan. Yang ini, these are all OS. This is all the operating system. Okay, this is one-to-one. That means the kernel itself only gives you one user thread. This one, the kernel breaks down into multiple user thread. Okay. Meaning, if I am here, okay, katakan this is a book, katakan kita nak buku pula. This is chapter 1, 2, 3, and 4. Okay, chapter 1 you should be covered by 3 orang. Chapter 2, 3 orang. Chapter 3, 3 orang. Chapter 4, 3 orang. Okay, so these are groups by itself. Yang ini pula, okay, satu buku, but now the book itself, here itself kita divide. Here itself kita divide. Okay, this is from 1 to 3. This is from 4 to 6. This is from 7 to 8, and this is from 9 to 10. Macam tu. And okay, ini grup 1, ini grup 2, ini grup 3, grup 4. Grup ni dah tak boleh pecahkan lah. Dia kena buat juga. It has to do it. In this case, group number 1 can manage, can pecahkan lagi. Pandai-pandai lah dia pecahkan macam mana. Okay. In this case, the kernel itself decides, okay, I'm going to run 1 to 3, but only one thread. So this has only limited resources. This process has limited resources. Okay, so this is what we say as a Windows runs on this. Okay, so next question that you might ask, which one is better? Is one-to-one better or many-to-one better? Well, it does not say which one is better. It's only better depending on the type of process that you are running. If you are running what you see every day, day in, day out, Microsoft Word, Excel, then a one-to-one is fine. Okay, but if you're running high-end, that means you're looking at your servers, then you have to use your many-to-one, because you do not want to break down the kernel into multiple kernels. Okay. Right. Now, in this case, pula, you have the same thing as one-to-one, but here you break down into many-to-many. Okay. Many-to-many. Sama juga, same thing, kernel broken down into multiple threads, but in this case, the process can be now broken as well. The threads can be now broken as well. So this here is the operating system. Okay, this here. What's the difference? Cuba you tengok nombor 1. Yang ini satu kernel bahagi kepada beberapa user kernel. Yang ini beberapa user kernel broken down into beberapa user kernels. Okay, so here the best is you can run, ini paling bagus ni, you can run so many other processes because you have the brain for each. Okay, yang ini satu otak je, satu otak kena control 3. But in this case, you have 3 otak berlainan and multiple operating system. Okay, so among the 3, actually, this is the best. Okay, this is the best. You have many. That means each is you can do so many more processes running at the same time. Okay, why do we need all this? Because if we are running like parallel programming, then you need all this architecture being done. Okay, so how do we set this architecture? How do we set your PC to run on a kernel or a multiple? You can do it. You have to do it during your installation, right? To set your kernel, your kernel distribution and kernel threads. All right. Next, we go into a different step. We also looking into a 2 level. It's almost similar to many. All right. Okay, next we go into thread libraries. What is a thread library? Okay, a thread library are services which belong to the particular thread. As I explained to you in the previous early slides, there are certain functions which are not allowed to be used in one particular thread. Contohnya, if thread number 1 is doing printing or saving, then thread number 2 and 3 and 4 cannot use these functions. They cannot use. But overall, all of these threads have something which is called a thread library. Thread libraries are all the functions available to be used by each particular thread. Okay, each particular thread. That means you can use these functions, tetapi ada beberapa function yang you cannot use because these functions are shared among all threads. Alright, so implicit threading, growing in population, number of thread increases, program correction more difficult with explicit threads. Okay, so when your thread increases, that means dalam satu proses tu you ada beberapa multiple thread running etc. So when you have these problems, when you have this, meaning then you are going to have when your thread increases, that means it will be more difficult for you to manage which process, which sub process is running. Okay. For example, contohnya, when you're running your, let's say, you're doing programming. You open Microsoft Word, tetapi you have multiple documents, or you open your, let's say, your Excel or your Excel. So you got calculation on document 1, you got calculation on document 2, you got calculation on document 3. So each of these are doing process by itself, a sub process by itself. Each of these are threading thread by itself. So when you have too many threads, now that will be difficult for the program to control, because each of these threads are doing something and reporting back to the process, because process can only be one. Tapi thread dia boleh banyak. So kalau you ada more than 3 threads or a lot more, then yes, your program will be finishing faster. Tetapi you might have some other issues whereby each program, the program will be exhausted lah. So dia kena buat thread ni sekejap, thread ni sekejap. Okay. So these are some of the disadvantage of having multiple threads. Okay. So in Java, this is the code. Okay, this is the code if you are running multiple threading at one point of time. Okay, so these yang ini pula, these are thread pools. Thread pools are all the, the programming side of the threading. Kalau you got programming, then you're talking about this. Okay, so these are all the programming issues. If you're doing programming, then you need to kalau kita buat lab nanti saya boleh ajar lah the codes on how to do threading as well, multiple threads. Okay, so some threads, yes, you can program it. You boleh buat programming, that means you run satu process and you got multiple threads. Ada certain codes that you need to run, but most of the time, the process itself can do multiple threading. Alright, so that is all for today. Very short chapter. So what we have done today is we have talked about threads. So you have to understand what is a thread and what is a core, single core, dual core. You need to understand how does a single core and dual core work. Also, you need to understand and also be able to write it down. And you need to understand multi-threading models. You need to know and explain what is a many-to-one, one-to-one, or n many-to-many multi-threading models. So if you are able to do this, then you have covered your chapter 4. All right. Any questions before we stop for today? Okay. Thank you so much for attending my class. Do not forget to sign my attendance. And inshallah, I will see you in the next class. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.